Let's process again that we did about this. First, you recognize what? Before you do anything. Degree of the numerator and denominator. Is in the correct relationship? 2 and 3. That's good. Then you factor the denominator. So you factor the denominator. X squared is a common factor, right? X minus 2 is a linear factor. 5x squared minus 3x plus 2. Is there a way to regroup it into a 2 group into no common factor, or 3 group and no common factor, or something like that? Clearly, right? X squared and x minus 2. Those have no common factor. Is that right? You look at it as x times x. Repeated linear factor. Correct? X minus 0 squared, or something like that. These two factors have no common, no linear factor. So they can be split like this, x squared plus x minus 2. Is that right? That was the partial fraction decomposition theorem. If there's no common factor, split it like this, right? And what was the degree of this x minus 2? 1, so degree of the numerator should be 0. So it's going to be some constant c, right? How about x squared? I'm going to call c prime because one more time. Degree of x squared is 2, so it's a linear up there, right? Degree of 1 is a worst you can get. Make sense? Now you have a repeated factor, correct? Repeated factor, therefore, it can be further decomposed. How does repeated factor decompose? If you look at the repeated factor, you write down irreducible factor of that repeated factor and one higher term all the way up to the full power. X and x squared plus x to the third plus whatever the power you see in there. And you write down polynomial degree less than the irreducible factor, which is constant a, and for that repeated factor, just repeat constant b again. That's what we just looked at. That's what happened to repeated factor. So that's the theory, and you have to figure it out. We don't know what a prime, x, and b prime is. If it is so, then we do the synthetic division a couple of times quickly. Then there's a quick way to answer ab, right? Synthetic division to a prime x plus b prime. But right now, that's some procedure you have to go through. So it's more efficient. Just figure out these, not going through synthetic division. So why did I do the synthetic division? To show you it's possible to write this one down to that existence of such decomposition is possible. I use the synthetic division. And I'm saying right now, in this mixed problem, synthetic division is not necessarily efficient method. If it is all by itself like that, then yes. My comment makes sense? It is not just one repeated factor, and that's not the whole problem. You have to, it appears in the middle, so you just enter it in here and deal with this one. It's better than thinking about using the synthetic division. All right, so once you decompose it like this, and then you have to watch out really logical step to get down there, and it makes more sense. Okay, these a and b saw the degree less than the degree of irreducible factor of this repeated situation. That's why it's all constant there. Okay, I'm saying this complicated like this. This repeated factor can be irreducible quadratic. Then what appears in there is a linear and linear, quadratic and quadratic squared, things like that. The principle is the same because it's long division. Okay, so you have to figure it out. So what are we comparing here? We know when you combine the denominator together into a common least common multiple, or things like that, and it matches exactly x squared minus times x minus 2, right? Pay no attention to the denominator. Numerator 5x squared minus 3x plus 2 is the numerator left hand side, right? When you combine the right hand side, see what you have to multiply to a, right? What do you have to multiply to a? I need one more copy of x there, right? Is that right? I need one more copy of x. I need that. How about denominator is here, x minus 2. There's no x minus 2. You've got to multiply that x minus 2 as well. To make the denominator of the first term x squared minus x squared times x minus 2, you need one copy of x and x minus 2. Does that make sense? How about b? Look at the denominator of the b. X squared. You got the full copy of x squared. So what is lacking here is x minus 2. So you've got to multiply that x minus 2. Get the denominator of that one common as the whole thing. Make sense? How about c? Let me just use c, all right? Not c prime. What should be multiplied to c? X squared? Is that right? That's all you need. So when there's repeated factor, you choose a correct order of a specialization. If you choose a non-repeated factor as a specializer first, it tells you a number quickly. All right, so here it is. This is different from book, and I claim that it's a lot faster than what book does. And book doesn't explain this method. Here's one. Where do we specialize it? X equals what? Not 0. Not repeated factor. Do that one first, and it helps you. That's what I was saying. When there's no repeated factor, it doesn't matter which order you do. But when there's a repeated factor, do the non-repeated factor first. And x equals 2. And what do you get on the left-hand side? 20 minus 6 plus 2. Is that right? Is that 16? 16 is the left-hand side. Right-hand side, it knocks down these two things, x minus 2, x minus 2, and you have c times 4. Is that right? So what is it? C4 is, the c is 4. So you have that one, right? Because of the repeated factor, if you plug in x equals 0, it knocks this one down, but you run out of the specialization, right? We have one more thing to take care of, but only special value you can have is 0 and 2. And that's why I'm doing this. If you have one thing figured out, clear that one first, rather than, independently try to find the other one. So step 2 is slightly different, or I use that c equals 4. This is special about that repeated factor problem, okay? So go ahead and plug it in there and get a new equation. 5x minus 3x plus 2 is ax times x minus 2 plus b times x minus 2, right? And what is that c? Is a 4x. Go ahead and plug it back in. And reduce that equation. 4x, if you subtract the 4x, what do you get? X squared minus 3x plus 2 equals ax, x minus 2, b, x minus 2. If there are really many factors, this technique doesn't work. But this is the level that you have to know for differential equation. If there are 5 factors, a complicated specialization reaches the limit. But 2 or 3, it definitely had advantage. So c is gone. We're looking at 2 equations, and you're staring at x minus 2, x minus 2. What comes to your mind? What are you going to do about the x minus 2? Can we somehow get rid of it, right? That would be nicer. If this one is saying that x minus 2 must appear as a factor in the left-hand side. It's magic. The theory says this is possible, right? And then it also implies that if there is a common factor of x minus 2, that must appear in the left-hand side as well. And do you see that? X minus 2 and x minus 1. It fits perfectly like that because of the theory. Theory allows you to guarantee that. There will be no chance that it's contradicting. So what do? Get rid of x minus 2, right? So it's x minus 1. Then after that, you have ax plus b. Is that right? That is absolutely right. So what is a? B minus 1. We got that. A, B, C. Okay? So, but it could be, slightly more complicated. You just expand it out, and it's quite easy to see how to figure out A and B easily. All right, let's go back. This is our thing, right? It's perfectly decomposed in here. So, our original problem, dx, is now like this. What's A is 1. What's B is a negative 1. And what is C is 4 and x minus 2. And then you just stare at that one. God, that looks so good. And then you can calculate immediately, right? That's how you do it. So what is the answer? ln x minus this one is not ln, right? there was actually 1 over x. And this one is ln x again, 4 times ln x minus 2 plus c. That is not first power, so you have to go through the substitution rule. No, it's not substitution rule, it's just usual x squared. But there are 2 ln's, right? What do they do in these 2 ln? They combine them together. It's a plus, and this 4, where's the 4 go? 4 goes to this exponent, right? And in front of it is a positive right there. So it's x times on x minus 2, the 4th power, is that right? And outside, there is this 1 over x all by itself. The antiderivative of this one, original problem, is written like this. That's when there's a repeated factor. Okay. Let's look at part A. Numerator degree is 2 and denominator degree is 4. So it's in the shape. X squared plus 1, and common factor there, x squared, right? So x squared factored out. And what else? X squared is here, negative 4x minus 32. Is that right? So this is not irreducible, the factor, but we'll do it. Just this quadratic factor involved in there. So what is that? Numerator x squared plus 1, x squared. Does this factor? 8 and 4. So it's x minus 8 and x plus 4. Is that right? Okay. So we have that. Let's see if we can write down. Oh, this one is only about setting up partial fractions. So sorry about that. So this is setting up the partial fraction. Not figuring out, we're just practicing the partial fraction. So what do you say? Let me write down like this. This is stuff we don't care about. But you agree that it's going to be split like this in the first level using partial fraction decomposition. These are all factors have no common factor, right? And they split it. This is degree 1, degree 0, degree 0, degree 0, degree 0, right? What about degree of this one over x squared? Degree 1 or less. That's what the first level says. But when there's a repeated factor, we can do further down, right? Is x over and x squared. Remember this? If there's a repeated linear factor, you can go down to this level. And right now, here's a degree 1, but you can go all the way down to degree 0, a and b. Make sense? And here, x minus 8c, and then linear factor, and x plus 4, and here's a d. That's what that is. Make sense? Now you combine these, but that's not what it says. Set up the partial fixes. This is a decomposition. Figuring out uses actually the same technique. If you use 8 and negative 4 and you figure out 2 coefficient and get rid of that part, and it's a lot simpler, right? So let's do part B. Part B is already factored, right? So how about this one? How are you going to factor this one? I showed you the 2 method of factoring quadratic yesterday. If it doesn't factor neatly over the integer. Quadratic formula and the one that doesn't factor, right? And we wish that doesn't factor so you don't have to do anything, right? But what was that? Discriminant, right? B squared minus 4ac. What is b? 2 is a 4 minus 4 times a and c. So that's less than 0, right? What does that tell you? Complex roots doesn't factor over the real. So that guy stays as it is. It's irreducible factor. Does not factor anymore. You don't have to factor. Okay? So let's write down the composition. X minus 2 is irreducible factor, and it is not inside x squared plus 2x plus 2. Right? There's no real roots in there. So they decompose like this. We know we're not going to do any more split about x squared plus 2x plus 2, right? So we can write down, cx plus d up there. Is that right? the numerator of these individual parts has to be less than a degree less than that. So that's a logical step. What about the repeated linear factor here? X minus 2 appeared, and the next power appeared, according to synthetic division, right? But here the degree possibly, this degree 2 is degree 1, but if you decompose it like this, it becomes degree less than the irreducible factor, which is a and b here. That's how the repeated factor splits. And cx plus d, this is not going to be decomposed. We're going to integrate this guy as it is right here. So when you see this type of thing, there's a technique you practiced recently. What do you do to the denominator? X squared plus 2x plus 2, that doesn't factor anymore. Complete the square, right? If you complete the square, it becomes x plus 1 squared plus 1. And this is in the tangent substitution, right? A squared plus u squared, right? So the tangent substitution is available. All right. But this problem is just about setting up the partial fractions. This is what I can do about next problem. Here's a 4. And all right, this is the actual problem that we're going to do. All right, first decomposition. That 7x squared, the rational function that we're looking at there. So how does it decompose? What about this one? Does that factor further? If this is a negative 3, it does factor further, right? So let's determine whether it's factor further or not. What do you think? B squared 4 minus 4 times AC. Less than 0 again, right? So we don't factor that. And there's no repeated factor. So how does that split? X minus 2 and x squared plus minus 2x plus 3. Is that right? And there's no repeated factor. And these are, they have no common factor. These have only complex roots. So what goes then above x minus 2? Degree 0, right? So a. How about this guy? Degree 1 less than that. What is it? Bx plus c? Now you have to figure out what a and b and c are. All right? So what do? You multiply denominator to get back to its own shape. So what's in the left-hand side, numerator? 7x squared minus 13x plus 13, right? That's in the left-hand side. Numerator. Right-hand side, let's think about it. What should we multiply to a? To get this product back in here. Now common denominator is x minus 2 times that. We got x minus 2 for the first term, but that part's missing, so we multiply top and bottom this factor here, right? So it's x squared minus 2x plus 3. That's going to be the numerator of this one as you combine into a common denominator. What about bx plus c? What are we multiplying? X minus 2. And then it's just two things become the same. The book encourages to expand all that, but don't expand it. Specialize it at the linear factor. I think it does good thing. It'll tell you what a is. All right, here's specialization. Which one are we doing first? Linear factor first, right? Linear factor. Well, we don't have special things to specialize here anyway, right? We don't have this complex number. And we don't want to deal with that. So we do x minus 2, x equals 2. That's one of the 0 that's available. So let's do that. Left-hand side, what is it? 28 minus 36 plus 13. It's a negative 23. I think it's a positive 5. Okay? Let's say positive 5 is correct. The right-hand side, what do you get? It's 2 as a times is a 4 minus 4 plus 3 is a 3. And second term disappears, right? Because x minus 2 is there. So what is it? A is 5 over 3, right? Let's check that again. 2, so that's 28. 2 here is the 26. not 36. So what do you get? 13 is a 13, right? So 28 minus 13, I think it's negative 15, positive 15, all right? So 5, better looking. A is 5. Now, to figure out, so A is 5, and this B and C is stuck together, and we don't have anything to specialize, right? So what do? Go back and plug in 5 and get rid of that portion. Move it to the left-hand side. So use A equals 5. Then 7x squared minus 13x plus 13 equals what? It's 5x squared, right? Minus 10x plus 15, is that right? Plus bx plus c times x minus 2, right? And what is it together? 2x squared minus 3x minus 2 equals bx plus c x minus 2. Isn't that right? Then how do we figure out b and c? It says x minus 2 is a common factor, right? So believe that x minus 2 is a common factor and see if you can figure out the rest of the part. So 2x, and I think it's negative positive 2. No, positive 1. Negative 4. It works. 2x plus 1. So right-hand side says that x minus 2 is a factor, and it seems like it's really the factor. And it tell you, and 2x plus 1 is bx plus c, right? So what's b? That. So let's go back to original problem. Is now becoming a is 5. B is what? 2x plus 1, and there is a denominator. How does that, if you complete the square, I think it becomes like this. Yeah. Now this is easy integral, and that one has to be u substitution x minus 1 and further tangent t substitution, so that you handle that square plus a constant in the denominator. All right? I was definitely rushing at the last problem, so I will not have this problem, example 4, in the test, but earlier 2 examples are pretty neat, and hope you study in this one tomorrow. 4th of July is the right date to do it, so so that you don't forget in the differential equation. But they rarely hit that level, but you have this interesting technique of calculating quickly, then comparing the coefficient and dealing with a 3x3 coefficient, matrix and things like that. All right, so you'll have your mock test.